All right, welcome to Bellwork Week 8. We're going to cover day 1 and day 2 in this video. All right, so our learning outcome for day 1 is a foundational target. You'll find this on your learning scale, and that is the student can determine the number of each type of subatomic particle in an atom. Okay, and I have a few notes over here at the top that we'll go over here in a second. But the question is, if an element has an atomic number of 16 and a mass number of 33, what is the number of protons? What is the number of neutrons? What is the number of electrons? And then what is the complete symbol? So we're going to go over all of those things. So if we look at the number of protons, we should know that the atomic number is equal to the number of protons. So that makes this first question very easy. If we know the atomic number is 16 from the prompt, and there it says it, then we should know that A is equal to 16 protons. And then we have B, the number of neutrons. Well, in our formula, we have mass number is equal to the number of protons and neutrons. If we rearrange this equation to solve for neutrons, we would get neutrons is equal to mass number minus the number of protons. So if we just plug in our values that we know, and we do know that the mass number is 33, because it says it right there, so we'll just plug that in under mass number, 33. And we know the number of protons is 16, because that's what we determined in part A. And so 33 minus 16 is going to be 17 neutrons. So we have 17 neutrons. So that's the answer to B. And then C, the number of electrons. Now this is a point I want to bring up, is if we have an atom, and we do have an atom has no charge, it's going to have a neutral charge, and I'm going to bring this up right here. Here is an atom, it has a neutral charge, and when it has a neutral charge, the number of protons is going to be equal to the number of electrons. All right. There are cases where we have atoms with a charge, and those are called ions. All right, and so if we have a negative charge ion, right, then we're going to have more electrons than we are protons. If we have a positive charge ion, we're going to have more protons than we do electrons. But in all cases, for right now, we're dealing with atoms, and they all have a neutral charge. So they're going to be, the number of protons and the number of electrons are going to be equal. Okay, so if we have 16 protons, that means, and we have an atom, that means we also have 16 electrons. And then last, we're drawing the complete symbol. Well, if we know we have something with an atomic number of 16, we have to find what element that is, and we can do that by looking at, you guessed it, our periodic table. So we search it high and low, and lo and behold, we find an atomic number of 16, and it is sulfur. So we will write the symbol for sulfur, and then we will simply make the complete symbol. In the complete symbol, we have a mass number of 33. That's what we were given. And then our atomic number is 16. All right, and that is our complete symbol for that isotope of sulfur. All right, last question on day 1. If an element has 50 protons and 68 neutrons, what is the atomic number? What is the number of electrons? What is the mass number? And then what is the complete symbol? So, okay, so in order to answer this, we first look at the atomic number, and that's going to be, you guessed it, the number of protons, all right? Because we know that atomic number and the number of protons are equal. So if we say that we have 50 protons, and it says that right here, 50 protons, that means we have an atomic number of 50. That's our atomic number. All right, B, number of electrons. We know we have an atom, all right? We have an atom. We talked about this just a little while ago. Atoms have a neutral charge. In order to have a neutral charge, they have to have the same number of protons and the same number of electrons. So if we say we have 50 protons, then we also must have 50 electrons. And then the mass number. We simply use the formula for mass number. Mass number is equal to the number of protons plus the number of neutrons. All right, and so if we have 50 protons and we have 68 neutrons, what is 50 plus 68? And that is 118. So we have a mass number of 118, or we can say 118 AMU. And then the last part is we do the complete symbol. In the complete symbol, we have to know what element it is. So we go to our periodic table. We search it high and low, and we find an atomic number of 50, and 50 is the element of 10. So we have 10, which has a symbol of SN. It's a capital S, lowercase n. You will not put capital S, capital N, because that is not the symbol for 10. It has to be, when you write the symbol, it has to appear just like it does on your periodic table. All right, and so then now we just simply put our mass number as our superscript, and our mass number is 118. We calculated that in part C, and then we put our atomic number as the subscript, and we found that in part A, and that is 50. And so this is our complete symbol for that isotope of 10. Now we will go to, now we will go to day 2, and let's go ahead and get there. And on day 2, we are calculating the average atomic mass. Our outcome here is that the student will use a mass spectrum plot, percent abundance versus mass number, to determine the number of neutrons in an isotope and to calculate the average atomic mass of an element. All right, so what we're really going to do in this assignment is just calculate the average atomic mass of an element. We have not quite got to the mass spectrum part of this yet, but we need to understand how this average atomic mass is calculated. So we're going to do that in this scenario. So you are to calculate the average atomic mass of bromine. One isotope of bromine has an atomic mass of 78.92 AMU and a relative abundance of 50.69%. The other major isotope of bromine has an atomic mass of 80.92 AMU and a relative abundance of 49.31%. Now, most of the time, these atomic masses are expressed as a whole number. Just in this case, they are not, and we'll talk about that a little bit later. So in order to calculate the average atomic mass, what we do is we first take our symbol. We have bromine, and we're going to say it's 78.92. And so you can take your atomic mass, 78.92 AMU, and you're going to multiply that by the percentage expressed as a decimal. And you get these rules from your handy-dandy notes. So in order to get this percentage expressed as a decimal, you simply divide by 100. All right, and then you're going to do the same thing for the next isotope of bromine, bromine 80.92. And so you have 80.92 AMU times 49.31% divided by 100. And now you just get your handy-dandy calculator out. And when you do, you should get something like this, 40.00 AMU, and you should get something like 39.90 AMU. And then the last step of your note says that you are going to add your results. So you simply add those two things together and you get 79.90 AMU. And that's as simple as that is. All right, the next part, it says how many protons, neutrons, and electrons are in each isotope of bromine. All right, because these are not whole numbers, we're gonna round those to the nearest whole number to make this easier to count. All right, so if we have bromine 78.92, we would round that to be bromine 79. All right, and in bromine 79, if we wanted to know the number of protons, we simply go to bromine on our periodic table, and we find the atomic number of bromine, and that is 35. So we have number of protons is 35 protons. The next thing is we're going to find the number of neutrons. Number of neutrons is equal to the mass number minus the number of protons. So if you know the mass number, is 79, and we know that because it's bromine 79. And we have 35 protons, so 79 minus 35 is going to be 44 neutrons. So our number of neutrons in this isotope is 44. And then the last part is the number of electrons. And we talked about this in the last page, and that when we have an atom, the number of protons and number of electrons are equal. So we're going to have 35 electrons. All right, for the next isotope, bromine 81, when we rounded to get to 81, our number of protons is going to be the same thing as for bromine 79. Because it's bromine, it has 35 protons. That's what makes it bromine, is that it has 35 protons. Now, the number of neutrons is going to be equal to the mass number minus the number of protons. All right, and so that is not 79, but 81, because now we're dealing with bromine 81, minus 35. And so what you get there is 46 neutrons. So our number of neutrons in bromine 81 is 46. And then our number of electrons is going to be the same as the number of protons, 35 protons. So what's the difference between bromine 79 and bromine 81? Well, let's look at that. We have bromine 79 has a mass number of 79. Bromine 81 has a mass number of 81. Now, why is their mass number different? Because bromine 79 has 44 neutrons, but bromine 81 has 46 neutrons. So the difference between bromine 79 and bromine 81 is the number of neutrons. So they're atoms of the same element, but they have a different mass. This one is 79, this one is 81. Why do they have a different mass? Because they have a different number of neutrons. All right. Thank you for watching, and please watch again.